Hello, this is Mr. Stansbury. I'm going to take you through the notes on special right triangles, 30, 60, 90. Okay. At the end of this, you should be able to say, I can describe the relationships between the side lengths of a 30, 60, 90, and those are degrees, 30 degree, 60 degree, 90 degree triangle. And I can apply angle relationships in special right triangles to solve problems. So, first things first, here's where this 30, 60, 90 triangle is going to come in handy. If you have an equilateral triangle, we know that all these angle measures here have to be 60 degrees, right? Because it's equilateral. All the sides are the same and all the angles are the same, right? Because if we take 180, just to remind you, divided by 3, we get 60. So all these angles have to be 60. Now, if we were to chop this angle right in half, basically drop an altitude straight down on that here, this is going to make a right angle. So if we look at just part of this triangle, like just one half of this, we have, let's see if I can make this as close as I can. We have this here, which is a right triangle. We know that this side length, let's say if, just for the sake of argument, let's say that this side measure here is 8. That means that this here is 8, and we cut this side exactly in half. So now that means this has to be 4. And then what we're going to do is we're going to figure out what this side right here is going to be, right? And we can do that with a squared plus b squared equals c squared. So the hypotenuse is 8, so that's the one that has to be the c squared. So we got to turn that into 8 squared. And then the two legs are 4, and then let's call this, say, x, I guess, for now. It's really probably a better name for that would probably be h for height here, but let's just call it x. That's fine. So we're going to have 4 squared plus x squared equals 8 squared, right? So there's 16 plus x squared equals 64. Subtract 16 from both sides, and we get that x squared is going to end up equaling 48. So we square root both of those, and we get x equals, so we are going to second square root 48, and we get 4 root 3. Okay, now I'm going to leave it as 4 root 3 instead of a decimal because this is going to help us find some special relationships here. So this here is going to be 4 root 3. Okay, let's look at a couple more examples here, and then after we look at a couple more, we should be able to start understand well what the angle relationships are of a, this here is 60 degrees, just like it was before, and since this got cut in half, this is now 30, so hence the 30, 60, 90 triangle. Okay, this one here, all they give us is this 60 degree angle right here. We got and so if this is 90, this is 60. If we do 90 plus 60, that gives us 50. And if we take 180 minus 150, we get 30 degrees. So we know that's 30. So this is one of our special right triangles. Now, we know that since this is basically an a equilateral triangle cut in half, this side here, twice 7, is going to be the same as this right here. So if this is 7, double that, and this has to equal 14. Okay, so then now let's do a squared, b squared, c squared, and see what we get. So again, the important part is that 14 has to be our c squared. Let's do 7 squared and x squared, or h squared, whichever one you want to do. So that's going to be 49 plus x squared equals, I don't remember what 14 squared is, 196. Subtract 49 from both sides, and we get, we're going to have to use this anyway, so 196 minus 49 gives us 147. So now we want to square root both sides, and we get that x equals, so we square root our answer, and we get 7 root 3. Okay, so this side right here, this 7 root 3 has got to go right here on this side here. So we have 7, 14, 7 root 3. And if you'll notice over here, we had 4, 8, 4 root 3. Let's look at another one and see what happens. But how about before we do that, let's take a quick little comedy break.
Hey, instead of enjoying this moment, let's take pictures. We take pictures of everyday life and act like we're capturing history. Unbelievable, the cat's asleep. Post that on my Twitter. It's because we have the cameras on our phones. Do we need that? It's not like 10 years ago we were like, I wish I could take a low-quality photo of my dessert. Text it to someone that's not interested. But I can't, so I guess I'll just eat it.
All right. So let's try this again, see what we can come up with for our two sides here. So this, again, is an equilateral triangle cut in half. So this 16, this side here got cut exactly in half. This originally was 16. So that means this is going to be 16 over 2, which is going to be a side length of 8. So now we can do 8 squared plus, call that x. X squared equals 16 squared. So we got 64 plus x squared equals, let's see, 16 squared gives us 256, right? So we're going to subtract 64 from both sides, and we get that x squared. I'll take that, subtract 64, and we get 192. 192, so we square root both sides to figure out what our x is going to be. So we square root our answer, and we get 8 root 3. So this here is 8 root 3. So now we have 3 different examples here that should help us figure out what the heck is going on with this. So if you'll notice here, we had 4, twice that is 8, and then this ended up being this side here, 4 times root 3. 7, twice 7 is 14, and then this side over here is going to be 7 root 3. This one is, this was 16, half of that was 8, so we have 8, 16, and guess what? This side over here is 8 root 3. So now what we want to do is we now know our ratio for these things here is going to be when we got a 30, a 60, and a 90 degree triangle. Across from the 30 degree side was our 4, 8, and 4 root 3. So let's simplify this. Let's divide. If we divide all these by 4, that means across from the 30 is 1. Across from the 60 was that side here times root 3. So that would be root 3. And then across from the 90 here was twice this side here. So if this was 1, twice that is going to be 2. And this here is going to be our going to be the same ratios every single time when we have a 30, 60, 90 triangle. It's going to be 1 root 3, 2. Okay, not negative root 3 and negative 2, but 1 root 3 and 2. Or you will often hear it called as a 1, 2 root 3 triangle. Okay, so with that, we should be able to, instead of go through and do the Pythagorean theorem over and over again, we should be able to simplify that and just use our ratio to figure this out. So if this side here is 11 root 3, right, just like that's the same as this side over here, it's the medium, the longer of the two legs. If I divide that by root 3, then I'll get this short side. So really 11 root 3 divided by root 3. Guess what? The root 3's go away, and this is going to be 11. And we now know that this 11 is going to be half of this side here. So this side's going to be 11 times 2 is 22. So then we've figured out our whole triangle here without having to do our a squared plus b squared equals c squared. We're just using our ratio. Okay. So again, if this here is 8, we got to get down to this side here, we have to take 8, divide it by root 3, right? Which we know we can't leave a root on the bottom. So we could say that's 8 over root 3, but that's not good. So we have to do the same thing we did before. We have to get rid of that root 3, so we multiply it by another root 3, top and bottom. So this gives us 8 root 3 on the top, and then root 3 times root 3 is root 9, which we know is, the square root of 9 is 3. So that's just going to be 8 root 3 over 3 for this one here. 8 root 3 over 3, which is not beautiful, but it works. Okay? And we know that this side here is going to be twice that. So we're going to go 2 of the 8 root 3 over 3, which is going to give us 16 root 3 over 3. And we'll call that good as well. So now we have all 3 sides of our triangle of the 30, 60, 90. Okay? We'll always follow this lovely ratio of 1, root 3, and 2. Okay? All right. If you have any further questions about special right triangles, please feel free to ask in class. Thanks.